Ignition sequence start.
Good morning, and welcome to this view of the International Space Station Flight Control Room at NASA's Johnson Space Center, where there's always a team of specialists on duty keeping an eye on the station's systems and standing by to work with the Expedition 65 crew members on their tasks of station maintenance and science support. Laboratory operations were the main focus this week for Commander Aki Hoshide and his American, Russian, and French crewmates as they work to advance research in a range of scientific disciplines and make good on the station's goal of being a center for out-of-this-world science investigations.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Nilofer Ramji. A Soyuz relocation, the return of the 23rd SpaceX commercial resupply mission, and working to remove carbon dioxide from the atmosphere on a spacecraft. What a busy week aboard the International Space Station. On Tuesday, September 28th, NASA astronaut Mark Vande Hei and Russian cosmonauts Oleg Novitsky and Pyotr Dubrov will take a short trek on the Soyuz MS-18 spacecraft, relocating it from the Rassvet module to the Noka multipurpose laboratory module. Undocking will take place at 8:20 a.m. Eastern. You can watch live coverage on NASA television, the agency's website, and the NASA app. A few days later, on September 30th, SpaceX's Cargo Dragon undocks from the International Space Station as it brings home samples from scientific experiments aboard the orbiting laboratory. Live coverage of the departure will begin at 8:45 a.m. Eastern. Don't forget to follow ISS_research on Twitter for all of the latest on the science experiments on their way home. As we turn to science, the 4-bed CO2 scrubber is being put to the test for removing carbon dioxide on a spacecraft. Based on the current exploration, environmental control, and life support systems and lessons learned from its nearly 20 years of operation, the 4-bed CO2 scrubber includes mechanical upgrades and an improved, longer-lasting absorbent that reduces erosion and dust formation. This technology could improve the reliability and performance of carbon dioxide removal systems in future spacecraft, helping to maintain the health of crews and ensure mission success. Did you know that alternative reality and virtual reality serve as helping hands aboard the space station? Here on Earth, experts are lending a hand to the astronauts. Both virtual reality and augmented reality serve as support for various activities aboard the space station. One of these is T2AR, which uses augmented reality to help crew members inspect and maintain the space station's T2 treadmill. Acting as a smart assistant, the AR application runs on tablets or headsets, interpreting what the camera sees and what the crew member does and suggests the next step to perform. Time perception is an ongoing ESA experiment to investigate the perception of time to humans during spaceflight. Crew members wear a head-mounted VR display, listen to instructions, and use a finger trackball connected to a laptop to respond. To learn more about the use of alternative and virtual reality aboard the space station, head over to nasa.gov. That's Space to Ground for this week. Thanks so much for watching. We'll see you next week.
The laboratories on the International Space Station provide a setting for scientists to do experiments that take the force of gravity out of the equation. For example, there's an experiment that's studying sediments of quartz and clay and focusing on the forces between particles that cluster together. Whether you're in space or on Earth, you have trillions of microorganisms on and inside your body. But many of them are essential to human health, and because of that, one study on the International Space Station is looking into how spaceflight may change those microorganisms and what that could mean for our body's internal systems. Scientists are using the International Space Station to learn more about the physical sciences too. For example, researchers behind a number of experiments on the science of combustion are hoping to uncover ways to burn fuels so that they produce less pollution.
The power of studying combustion on the ISS. Presented by Science at NASA. If you wanted to reduce the amount of pollution humans produce, where might you look? Here? Yep. Here? Sure. Here. Wait, what? That's exactly where scientists and researchers are looking, about 250 miles above Earth on the International Space Station. Here, astronauts are working on a series of experiments to learn more about combustion. Why combustion? Dennis Stocker, project scientist for the Advanced Combustion via Microgravity Experiments, or ACME, says, consider this. About 85% of the energy we use comes from combustion, the burning of some sort of fuel. About 70% of the electricity that we use at home and work comes from power plants that use combustion. The combustion of fuels powers the engines in many modes of transportation. Stocker continues, if we can learn more about the process, we might be able to find newer and less polluting ways to burn fuel. 3 series of combustion experiments taking place on the International Space Station's Combustion Integration Rack, or CIR, are looking at combustion in very different ways. The Flame Extinguishment Experiment, or FLEX, examined the burning of a single droplet of fuel in the microgravity confines of the ISS. The last of the droplet combustion experiments were conducted in September 2017. ACME began in November of 2017. ACME is composed of 6 major experiments, with each taking about 5 months to complete. These experiments will examine how various gases burn without gravity affecting the flames. The Solid Fuel Ignition and Extinction, or SOFI experiment, will explore the properties of burning solid matter. So why study combustion in microgravity? As Stocker explains, on the ISS you have conditions that you can't replicate on Earth. For example, consider a candle when it's burning. The flame flickers. Why? Hot gases from the flame rise, while cooler, denser air is pulled to the bottom of the flame. This flow occurs at high speeds, resulting in turbulence and instability. That instability makes it hard to study the properties of the flame. But on the ISS, there's no flicker, which allows us to make more precise and consistent measurements. If we have precise measurements, we get closer to learning how to burn more efficiently. More efficiency could lead to real cost savings for producing power. The research could also lead to reducing the production of soot and other pollutants. Combustion experiments conducted in space have contributed to practical applications on Earth, especially in the field of fire safety. A new type of fire extinguisher is just one example. And as Stocker notes, I think we're in for a few more surprises as a result of these microgravity experiments. That's because, not surprisingly, Stocker knew where to look for answers to reducing the amount of global pollution. He looked up. For more from the International Space Station, go to www.nasa.gov/station. If you're burning to learn more about other hot science topics, visit science.nasa.gov.
There's also science about space and science to support future space exploration. And as we've mentioned already, there's science being done on the International Space Station that's aimed closer to home, helping improve the lives of us Earthlings who never get to leave the planet. Take a look at just a few examples.
The International Space Station is the most fantastic vehicle ever built.
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world.
And the result will help benefit the people on the ground.
Space Station really provides an opportunity to explore, for example, say medical applications.
The aging and the osteoporosis and muscle wasting conditions are greatly accelerated in microgravity.
The weightless environment will give us insights into things like diabetes and maybe even cancer.
Understanding those phenomena allow us to look at how we can improve treatment of disease here on Earth.
If we wouldn't have conducted experiments on the ISS, we wouldn't have known that you could use cold atmospheric plasma in such broad application areas we're now exploring.
One of the most promising results has been gained by studying a protein associated with Duchenne muscular dystrophy.
We may be able to slow the disease by half, potentially doubling the lifespan of many of these DMD patients.
We provided iServe imagery for many natural disasters, including floods and fires, for deforestations, for volcanic eruptions, and for earthquakes. So it was really a fantastic example showing how imagery from the International Space Station could be used in these times of dire need.
This was when we realized we had a chance to make a difference in the world using the same technology that was used by NASA, but applied in a remote area of a developing country.
I think it's made people much more aware of the issues of water quality. That's a very powerful thing.
Having the HyCO on the International Space Station has been the ideal test bed for our research.
We can monitor these water bodies from space, and if we can reduce exposures both to humans and even animals, then we've achieved our goal.
And now today, we're able to operate the largest fleet of Earth imaging satellites in human history.
And none of that would have been possible without the International Space Station.
The space station has done so many things for life on planet Earth. It shows us what human beings can do working together. It shows the science that we can discover.
Over 2,000 experiments have flown on board ISS. 170 countries around the world have participated in some fashion, either in the ISS itself or in one of the experiments. Our rate of research is actually increasing. We're doing more today on board the space station for research than we have ever done before, and that's only going to continue in the future.
And so what we're seeing today is a proliferation of new ideas and new concepts. It's almost like it's a renaissance of what's happening in space. Buckle up and strap down, because this is going to be a rocket for all of us in the global community to be part of.
For the last 18 years, NASA's Hunch program, High Schools United with NASA to Create Hardware, has challenged students to use the technical skills they learn in class to build replicas of space station hardware. But now, Hunch program organizers are challenging students to build actual flight hardware for use on orbit.
When we first started with Hunch, we started with 3 schools, 2 in Alabama, 1 in Texas. Now we're up to 77 schools, 34 states, 7 NASA centers. Everything from CAD drafting, design and prototyping, welding, computer electronics, anything that you fly as a mock-up or emulate as a mock-up for space station, we do it on the ground.
First year we did 2 or 3 little projects for them, and the next year it got a little more advanced, and ever since then it's just gotten more and more technical and more challenging and more rewarding. I think it's important for students to be involved with Hunch because it gives them real-world applications that they can take into their occupations as adults.
When I talk to my friends about it, they don't really believe it very much. To say we have parts going to space as a senior in high school, going out on a spacewalk, it's pretty amazing. And
I like seeing the light bulb go off. To me, it's making that connection. You know, it's stuff that I know how to do, want to do, but I let the kids do it, the students do it. It's just a heartfelt fulfillment to me because it's success, and that's what we need.
One of the best parts of being an astronaut on the International Space Station, or so I'm told, is the ability to look out the window for a living color view of planet Earth. In this demonstrations episode, astronaut Randy Bresnik discusses the station's role as an Earth monitoring and diagnosis station, while showing some of the amazing images he and his crewmates have captured from 250 miles up.
Hello, I'm astronaut Randy Bresnik. Want to know one of the best parts about being an astronaut up in space? Our view of the Earth from the International Space Station is absolutely spectacular. And viewing the Earth from space is a big part of our job. In addition to many other important functions, the International Space Station serves as a global monitoring and diagnosis station where we can conduct observations across the globe, aimed at understanding and resolving environmental issues we face on our home planet. Let's have a look. The space station offers a unique vantage point for observing the Earth's ecosystems with hands-on and automated cameras and image capture equipment. These tools enable astronauts to both observe and explain what they're witnessing in real time. The image capture equipment on the space station also provides input to personnel back on Earth, working to program the station's automated Earth sensing systems, providing flexibility and an advantage over sensors on unmanned spacecraft and satellites. Scientists and researchers find this especially useful when unexpected natural events such as volcanic eruptions, earthquakes, hurricanes, fires, and other natural disasters like floods occur. Through existing international and interagency partnerships fundamental to the International Space Station, data sharing that can benefit people around the world is facilitated, promoting international collaboration on a range of Earth observation activities. A wide variety of Earth observation equipment can be attached to the space station's exterior, like I did on one of my spacewalks. Several instruments have already been installed, and researchers from around the globe are proposing additional payloads to install. In continuing to use a combination of crew-operated and automated Earth observation payloads, the space station collects crucial data on the global climate, environmental change, and potential hazards to the health of humanity and our home planet. The Window Observational Research Facility, or as we call it, the WRF, provides a highly stable internal mounting platform to hold cameras and sensors. With the WRF, the high-quality optics of the nadir, or the bottom viewing window of the space station, allows us to look straight down onto Earth. Do you want to participate in some of our Earth observation missions? Come join us. Check out the Sally Ride EarthCam website. Go to earthcam.org and follow the instructions to sign up. and have a look at some of the spectacular Earth views from space and see what you can identify. You can also try the activity in the link we provided in the description of this video. Thanks for joining me. See you all next time.
Expedition 65 Commander Aki Hoshide and mission specialists Shane Kimbrough, Megan MacArthur, and Thomas Pesquet flew the Crew Dragon Endeavour to the International Space Station. Before their launch, we tested what they know about each other and what they think they know about each other as they were looking forward to going to space together for 6 months.
Megan, intelligent, witty.
She's smart, knowledgeable, and she's brave.
Shane is thoughtful, but also a prankster.
Calm and smooth.
Aki, always smiling.
Competent, funny, and a good friend.
Thomas, extremely skilled and fun.
Thomas is gregarious.
Playing golf.
Baking.
Ugh. I'd say French.
Japanese. I know Soichi answered it that way too.
Me. I have OCDs, so it's in my ballpark.
Well, I have good experience with Thomas. He and I are very tidy, both of us. It's still, the jury's still out on Aki and Megan.
I'm relying on Shane's Army experience to keep us in shape up there.
Me.
Me.
Me, definitely.
Me. Because I always make them laugh for some reason.
Just enjoying life together in microgravity. It's such a special environment, and getting the chance to do that with Megan, Thomas, and Aki is going to be very special. And of course, landing with them is going to be really exciting.
Karaoke night.
So just hanging out on the space station, working together, living together, spending some precious time with each other.
Aki.
Maybe me?
Well, I don't know. Pretty much all of them. I would say Megan has a great poker face. The rest of us were pretty bad.
Probably not me.
I think Shane would win in a foot race.
Thomas.
That's a tough one. Shane runs every day, but I think Thomas would be highly motivated to win, so it would be very close.
But we'll have to figure that out. We'll have to try.
I don't know that. You'll have to ask them.
It turns out I'm an interrupter. I come from a talking people, so I have the tendency to interrupt.
I speak.
But I'm working on it. I'm sorry, did I interrupt you there? Let me just...
The fact that the members of the Expedition 65 crew have been in space a while now doesn't mean they don't still get a thrill when they look down on the panoramic view of Earth. Former station crew member TJ Creamer has a few thoughts about the impact of his first views of the natural wonders of Earth from this one-of-a-kind viewing platform.
And liftoff.
10 seconds.
I think what you get a sense of is just how awesome the universe is and how tiny each of us are in the grand scheme of the wonder that exists out there. Realizing that and realizing just how overwhelmingly huge the Earth is, how overwhelmingly the physics dominates what we're doing, and that we're living in this solar system, galaxy, universe, lets you know that this is someplace kind of special. To be a part of the mission that serves on station, to be part of the mission that goes exploring space into this vastness is simply, one, an honor, but two, almost mind-changing. Mind-changing because we have businesses, we have missions here, we're focused on accomplishing the near-term goal. You get up there and you see the overwhelming portion of the Earth, the vastness that you're exploring into, and you go, wow, there is just so many questions, so much for us to do, so much for us to be able to help our brothers and sisters with. We had a special opportunity on the space station because of the window arrangements to be able to seriously get immersed in the imagery. Going to the windows to watch areas that were of great interest. Patagonia, for instance, is just a beautiful, rich environment of earth tones as well as the glaciers, the water. It is just picturesque to the point where you go, I need to go visit that place. You want to find things on the Earth because it is memorable, but also insightful. For instance, you're going over a tan and you go, oh, you know what, I bet you I'm close to the pyramids. And so you go to the window to take a look at if you are close to the pyramids, and then take some shots that you can take home. There are areas of the world that have volcanoes and you just happen to catch in one photograph 2 or 3 active volcanoes. It's a nice experience to be able to look out the window and go, wow, we really are seeing the living Earth living, and being able to be a part of it from such a vantage point. We saw Hades troubles while we were up there. The Gulf oil spill from the horizon occurred while we were up there. A number of hurricanes or tropical cyclones occurred while we were up there. You know there's a ton of energy in there. You know it's heading towards populated areas. It's not beautiful at that point. It's utter respect is what I would categorize it. I got visited by 3 space shuttles. Several of the crew members never looked outside the cupola before. I would bring them one at a time to the cupola. Tell them to close their eyes, open up all the windows, the shutters on the windows, and then tell them to open up their eyes. And that instant, when you're overwhelmed with that vista, when your eyes see nothing but the beauty of the Earth, every single one of them, every single crew member that I brought in there for that exposure cried. It is heart-stopping. It is soul-pounding. It is breathtaking.
Would you like another look at any of these stories? Well, you can always find them on YouTube and Facebook. They're there with a lot of other great features on a whole variety of NASA topics. And if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, a weekly show with interviews about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan highlights Hispanic Heritage Month in a conversation with 2 Johnson Space Center workers involved in the Hispanic Employee Resource Group. Go to nasa.gov/podcasts for this week's episode and all the previous episodes, and the full library of all the NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.